Now let's practice using significant figures. I've gotten them mixed up in here, but remember that the rules when we're doing addition and subtraction and when we're doing multiplication and division are different. So in number 1, we're doing 47 divided by 2.2. And we get 21.36 repeating. And since this is division, we know that we're going to have the same number of significant figures as the original number with the least. This one has 3 and this one has 2, so we're going to round this to 2 significant figures. We're going to have 21. Now we also have to consider our units. I'm making you guys practice with units here. And we have meters divided by second. Nothing cancels out there, so we have meters divided by second. Doesn't change how we do the math, which is what I want you to notice. In number 2, we're doing subtraction, and what we get out of our calculator is 1821.1. And we remember when it's addition and subtraction, we're counting decimal places. So this has no decimal places and this has 1. So we're going to round this to have no decimal place. And we're going to have 1821 milliliters. When you're doing addition and subtraction, make sure that the two values are in the same units. Otherwise you can't add or subtract them. In number 3, we have division again. You get a little bit more than 156 in your calculator. So because it's division, we're going to count significant figures. This has only 1, and this has 4. So we're going to round our 156 to have only 1 significant figure. So we're going to round that to 200. And it looks like I left the units off there, so we're going to say the units are per milliliter. We could be counting 200 per milliliter. In number 4, it's multiplication. And you get 49,000. And if we count our significant figures, we have 5 and we have 3. So that means, let me write 49,000 over here for a second, that we have to make that 0 be significant, but not the other two. The only way to do this is with scientific notation. So we're going to say 4.90 times 10 to the 4th, and it'll be centimeters squared, because we have centimeters times centimeter. In number 5, 3.45 plus 0.79. And you get 4.24864. And remember, it's addition, so we're counting decimal places, not significant figures. We have 2, we have 5, so we're going to round our answer to 2. So we get it to 4.25 because the 8 makes it round up. Pretend the units were on there. Centimeters. In number 6, you get 104.45. And we're counting decimal places again. So we have 3 and we have none. So we're going to round this to 104 milliliters. In number 3, we're doing division. And you get 140,000. And if we count our significant figures, we have 2 and we have 3. So it's already written with 2 significant figures as long as we don't put a decimal. We could also put it in scientific notation if we wanted. We could say 1.4 times 10 to the 5th, but they're the same number. Don't forget our units, kilojoules per minute. In number 8, you're doing 2 different calculations. But since they use the same rules, it's addition and subtraction, we're not going to round to the very end. If it used two different rules, if we had addition and division, we'd have to round in the middle. But for this, we'll do all the math at once. And we can see no decimal places. So we have 200 and milligrams. In number 9, we're doing multiplication again. And we get 46717,200. And if we count our significant figures, we have 3 and we have 5. So that means that these 3 are going to be significant and none of the rest are. We have 2 ways we can write this. We can write it like this. But the more zeros you write, the more likely you are to make a mistake somewhere. Look, I left a 0 off. Let me squeeze it in. So with large numbers like this, I prefer that you write them in scientific notation. 4.67 times 10 to the 3/7, and it's meters squared. And that's much easier to read and much quicker. I don't have to count any zeros. I can just look at your exponent. Let's look at this last one. You can see where we've got division and addition. So we're going to have to do them one at a time and round in between. Because of the parentheses, we're going to do the addition first. So we have 0.5 plus 0.025. And this has 2 decimal places and this has 3. So we're going to round this number to have 2. So we're going to say point. When we do the math, we get 0.525, and when we round it to 2 decimal places, we get 0.53 liters. So now we're going to do our division, 0.4002. And we get 0.75509,434. And because we're using division now, we're going to count significant figures. We have 4 and we have 2. So we're going to round our answer to have 2 significant figures. And we're going to get 0.76 moles per liter. Hopefully this was a good review for you. If you took chemistry here at Forest Trail, then you've been using significant figures, but I wanted to make sure that 1, you knew it didn't change the rules when there were units, and 2, that you remembered how to do it, because we're going to use significant figures in every single chapter and in almost every assignment. Please let me know if you have questions and try some of the practice problems below.